Good morning, students. In the last class, we discussed about the nomenclature of the coordination compounds. Okay. In the today's class, we are going to discuss about the isomerism. Isomerism in coordination compounds. So, in isomerism, again, two types is there. One is structural, another one is stereo. Structural isomerism and stereo isomerism. Again, in this structural isomerism, further four types is there. So one is ionization, next linkage, next coordination, next hydrate isomerism. Okay, so in this stereo isomerism, again two types. Geometrical, optical. Okay, so again these two further classified as cis trans. This is further classified as dextro. So students, this is all about the isomerism. The classification. This is a simple classification. So here, what is isomers? The compounds having the same molecular formula, but they show different physical and chemical properties. Then they are said to be isomers. And that phenomenon is called as what? Isomerism. So in that coordination compounds, isomerism shows two types. That is structural isomerism and also stereo isomerism. So here, what is structural isomerism is the compounds having same molecular formula but differ in their structure. Understood? Differ in their structure. Here stereo means the compounds having same molecular formula, same structural formula, but they are differ in the arrangement of atoms in the three-dimensional space. Understood? Here same molecular formula, different structural formula. Here same molecular formula, structural formula and different arrangement of atoms around the central metal atom or in a three-dimensional space. For example, here I will take one example. If any coordination compound with XY2 AB6 type is there or AB5 type is there, assume. Okay, so both the molecular formulas are same. So then what happens? It may attain this structure or it may attain this structure. The molecular formula same, structural formula is different. Okay, so there may be a change in this ionization, linkage, coordination, hydrate means the ligands must be different. Okay, so this is a type of structural isomer. Just I give an example. This is not exactly how I told you students. Okay, so here the compounds having same molecular formula but different structural formula. So the ionization isomers means upon ionization they gives different ions. Linkage isomer means in the bond A-B bond is there. This bond is different with respect to different metals. But AB is there, this is AC. And this is AC, AB, like that. So that shows what? Linkage isomer. Coordination means that is depends upon the central metal atom. Understood? Next, hydrate means depends upon the water molecule bonded to the atom. So I will explain detail. Okay. So stereoisomer means same molecular formula, same structural formula. For example, AB4 is there, So its molecular formula is also same, structural formula is also same. Or you may AB2C2U2. So here same molecular formula, same structural formula, but different what? Arrangement of atoms. So here AA is there, BB is there, means next this become AB, AB. Understood? So here the structure is same, square only, and the square planar only. Here all the ligands are same. This is not A. B, B, C, C, B, C. Okay. Here molecular formula both is same. A, B2, C2. Understood? And the structural formula is also same. Square. Square planar. Only the change in what? The arrangement of the atoms around the central metal atom that results in what? Stereo. Stereo is particular position. Okay? So that type of isomer shows stereo isomers. This is the types of isomers in this one is. These types are there. We will discuss one by one. Okay? So first I will go with the ionization isomer. So students, here first one, ionization isomers. Okay, ionization isomerism. So students, here I will give example first, then I will say definition. So listen, I take cobalt NH3 4 times NH3 4 times Cl2 Br. This is the molecular formula. Assume this is the molecular formula. I didn't write any complex here. CONH34Cl2 Br. If this type of compound is treated with AgNO3, if this type of compound treated with what? AgNO3. If it gives white color precipitate, that means CO NH3 4 times Cl Br Cl. If the compound is like this, then if it is reacts with AgNO3, then it gives what? CO NH3 4 times Cl Br NO3 plus AgCl. This is white PPT. Okay, so if we assume it gives yellow precipitate, that is CO NH3 4 times Cl2 Br. If it is treated with AgNO3 solution, then it gives CO NH3 4 times Cl2 NO3 plus AgBr. This is yellow PPT. Okay, students. So here these two molecules having the same molecular formula CO NH3 4 times Cl2 Br. But upon reaction with AgNO3, one give white precipitate, another one give yellow precipitate. What is the reason for this white and yellow precipitate? dissociated because if we consider these two, this is 1, this is 2. So first compound how it is dissociated? It is 4 times ClBr plus Cl minus. Correct? Second one dissociated as CONH3 4 times Cl2 plus Br minus. So in the solution they give different ions upon ionization. So these type of the compounds are in the same molecular formula, but they gave different ions upon ionization, or they give different ions in the solution. That's why they are called as what? Ionization isomers, and the phenomenon is called as ionization isomerism. So here, this is the example, correct? So if we got AgCl, a white precipitate, then Cl is dissociated as a simple ion. If we got yellow precipitate, then Br is precipitated as Br is dissociated as a simple ion or a counter ion. So this two structure gives the ionization isomer. Or these two is called as what? Ionization isomers. Understood? So this is upon ionization, if the complexes give different counter ions, then they are said to be what? Ionization isomers. I hope you understood. Now I try the definition, students. The compounds having same molecular formula but they give different counter ions upon ionization. Called as ionization isomers, and the phenomenon is called as ionization isomerism. Okay, so this is the example. You may take it. Okay, but so in the examination, the last students directly they will write. So how the question will ask? CO NH3 Cl2 Br and CO NH3 Cl Br Cl shows which type of isomerism important for 1 mark. So not only this ionization isomerism, they give two types to mark two different coordination compounds. Among them, they told you to choose which type of isomerism is exhibited by these two complexes. This is the way they arise the question in the examination. Okay. So this is ionization. Isomerism means the compounds are in the same molecular formula, but they give different counter ions upon ionization, called as ionization isomers, and the phenomenon is called as ionization isomerism. So this is the example. These two is the example for ionization isomers. Understood? Okay. So similarly, Second example I'll give. I think you know salt analysis. In salt analysis, three radicals are there. So first group acid radical CO3 2 minus. Second group acid radical Br, Cl, etc. Iodine or nitrate. And third group acid radical is sulfate. Okay? Here I take the example. Listen. This is CO NH3 5 times 4 times SO4. Okay. So students, if I will just take the example like this. This is the molecular formula. We don't know which type of compound it is. Okay. So here there may be a possibility of this one is so listen students. Here if CO is there, NH3 5 times SO4 into Cl. This is one type of compound. And CO NH3 5 times Cl SO4. This is another type of compound. Okay? This is one type of compound. This is another type of compound. Both are having same molecular formula. So how we can distinguish which of the following? So this one, which complex it is, either this or this one. If you treat the respective compound with AgNO3, if it gives white precipitate, then this is the correct answer. If it gives white precipitate, that is HCl, then this structure is correct. If not, then treat this with PaCl2 solution. You know, third group acid radical detection. So it gives white precipitate of what? BaSO4, then this is correct answer. If with AgNO3 gives white precipitate, then this is the correct answer. If with BaCl2 it gives white precipitate, then this is the correct answer. So these two also represent what? The ionization isomerism. Understood? So this is the first type of isomerism. So the second one is linkage isomerism. Linkage isomerism. So again I will explain example for students, that is Cu SCN 4 times 2 minutes. Okay, this is what CuSCN 4 times 2 minutes. This can be written as Cu SCN 4 times 2 minus or Cu NCS 4 2 minus. So students, this linkage isomerism can be shown by the complex are exhibited by what? Ambidentate ligands. Ambidentate ligand. So this is SCN and LCS is the example for what? Ambidentate ligand. What is ambidentate? In the same molecule or in a unidentate ligand. So one or more tonal atoms are present, then they are said to be what? Unidentate. So through sulfur or through nitrogen. In the same ligand, two atoms are there. Understood? Next, at the same time, Cn is there. Here, it can bond with carbon as well as nitrogen. Again, NO2 is there. So, in that NO2, it can bond it through nitrogen or oxygen. So, these type of ligands are called as ambidentate ligands, and this linkage isomer is exhibited by what? This ambidentate ligands. If any of the molecule consists of a coordination compound is bonded to the ambidentate ligands, then there may be a possibility of exhibiting linkage isomerism. Okay, so write the definition, then you came to know students easily. So different things. The compounds having same molecular formula but differ in the mode of attachment of ligands with central metal atom. With central metal atom paradise linkage isomers and the phenomenon is linkage isomerism. Okay, so here important thing, ambidentate ligand shows linkage isomerism. Okay, I'll write the example here, students. So CO5 times SCl. Okay. Next, you may also write it as MnCO5 times NCS. Okay. Next, CO H3 3 times into 3 times. Next, CO NH3 3 times ONO times. So here I write the structure, then you get to know. So Mn is there. Here CO, 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 CO. Correct? Next here Here it is bonded through SCN. So another one, Mn is there, same CO, but here it is bonded through NCS. Understood? Similarly, here CO, NH3, NH3, NH3. So NO2, NO2, NO2. If you consider here CO, NH3, NH3, NH3. So this is ONO, ONO, and this is ONO. Yes, students, the linkage here is through what? Sulfur. Here linkage is through what? Nitrogen. So here linkage is through nitrogen. Here linkage is through oxygen. So this type of linkage, this type of compound shows linkage isomerism. So in the ambidextrous ligands, the number of donor atoms present in the same ligand, the linkage will be different. So in the one compound, S is the donor atom, here in the another, nitrogen is the donor atom. So this type of compound shows linkage isomers. Okay, this is all about linkage isomerism. So third one is coordination isomerism. Okay, so the next one is coordination isomerism. And write the example first, then you came to know students. So here, example CO, I will write example here. CO, NH3 6 times, and Cr, Cn 6 times. This is the one type of a compound. So another one is this one. Cr, NH3 6 times, CO, Cn 6 times. So what is the difference here you are observing here, students? So listen, CO NH3 6 times, Cr Cn 6 times. So in this molecule, Cr NH3 6 times, CO Cn 6 times. Understood? So here what happens? These two, not these two, these two. Okay? So this one and this one. Compound 1 and compound 2 shows coordination isomerism. So what is this coordination isomerism means? The compounds are this type of isomerism is exhibited when the cation or anionic species are interexchanged between the molecules or compounds. So listen, assume here you assume with respect to cation. So here CO is the cation, Cr is the cation. Here Cr is the cation, CO is the cation. So interchange of cation takes place. Are you being considered? This is the anion. Okay. Here CO is bonded to neutral molecule, Cr is bonded to anionic species. At the same time, here Cr is bonded to neutral molecule, CO is bonded to anionic species. So here either interchange of anionic species takes place or interchange of this cations takes place. So this type of interchange results in one coordination isomerism. Here the coordination of the cobalt is 6, but it is coordinated neutral molecule. The coordination of the chromium is also 6, but the nature of the coordination compound here, the coordinate bond here is an ionic. Understood? So these type of examples, this type of compound shows coordination isomerism. Okay? So example for that is not example, that is definition. Okay, what is the definition for that? This type of isomerism arises, or we may say this type of isomerism arises when interchange of cations, interchange of cations and anions, cationic and anionic entities takes place between two different compounds. The main thing is the interchange of cationic and anionic entities takes place. If you write the proper definition, students, the compounds are in the same molecular formula, but they differ or the isomerism exhibited by the interchange of the cationic and anionic entities. Then they are said to be what? This coordination isomers. Here, this is the example. In these cases, either you consider means cobalt replaces Cr here, correct? And Cr replaces cobalt. Understood? If you consider here, NH3 replaces Cn and Cn replaces NH3. Either cationic or cationic or anionic interchange between the two compounds takes place. So that type of compound shows what? Coordination isomerism. Here what is the central metal atom exchange takes place. You remember this thing. Understood? If the central metal atom exchange takes place, then it is coordination isomerism. Understood? Okay. So the last one is hydrate isomerism. In structural isomerism, the last one is this hydrate isomerism. So students, what is hydrate? The name itself says hydrate. Hydrate means what? Water molecule. So this is also called as solvate. It is also called as solvate isomerism because water is what? Water is a solvent. So hydrate isomerism or solvate isomerism. So here what happens, students? So the compounds are in, here I will write the example first. So example for this is CO NH3 3 times, H2O 3 times, Cl3 assume. Okay. Another one is CO NH3 3 times, H2O 2 times, Cl2. Or you may take CO NH3 3 times Cl3 into H2O. Okay, so it is this one, structure 1, structure 2, and structure 3. All these three represents what? The hydrate isomerism. Hydrate means specially based on what? This water molecule. So, you may think here different ions are there in the outermost, sorry, outside the coordination sphere, here the number of atoms are different. So here there is no Cl means here it may, these two may show ionization isomerism, but water is not a ion. Understood? H plus and OH minus is an ion, but water is a neutron molecule. We can't distinguish them like what? Ionization isomerism. So students, only one thing is there. If two compounds are there, in that two different number of water molecules are bonded with the center metal atom, then they represent what? That hydrate isomerism. What it is? So listen, this is secondary linkage, correct? Here, this one shows what? Secondary valency. Here, three water molecules are bonded to what? Secondary linkage. Here, two water molecules. Here, zero water molecules. So students, these two represents what? If the number of water molecules bonded to the central metal atom are bonded through secondary linkage is different, then they are said to be what? The hydrate isomers or a sulfate isomers. Here the molecular formula is same. What it is? One CO is there, NH3 3 times is there, H2O 3 times is there, Cl 3 times is there. In all the compounds, all the number of molecules is same. Nothing is changed. So molecular formula is same. Only the thing is, in the secondary linkage of first compound, three water molecules are directly bonded to cobalt. Here, two water molecules is bonded to cobalt. Here, zero water molecules are bonded to cobalt. So in the secondary linkage, number of water molecules is different. So this type of isomers or this type of compound shows what? Hydrate isomers. So the hydrate isomerism or solvent isomerism means the coordination compounds are in same molecular formula but differ in the number of water molecules bonded to the secondary linkage. Okay? So, here a great definition. Coordination compounds having same molecular formula but differ in the number of water molecules bonded to the central metal atom as a ligand. But they differ in the number of water molecules bonded to the central metal atom as a ligand called as hydrate isomers and phenomenon is called hydrate isomerism. Okay, so this is the example for hydrate isomerism. Okay, students. So in today's class, we discussed about four different types of structural isomers of the coordination compounds. In that four, ionization isomer is there, and linkage isomer is there, coordination isomer is there, hydrate isomer is there. So what is the ionization isomers? The compounds having same molecular formula but they give different counter ions when they undergo dissociation. Okay, upon ionization they give different counter ions, which results in what? The ionization isomerism. Okay, so second one is linkage isomerism. If any of the coordination compound is bonded to the ambidentate ligand, ambidentate means the same donor atom or the same ligand, two or more donor atoms make the same. So in that type of ambidentate ligands, the linkage through the donor atoms, for example, SCN if we take means through sulfur it can bond to nitrogen, it can bond. So in the same ligand, two donor atoms are there. So that type of coordination compounds means having the same molecular formula, but they show different linkage in the same ligand. Okay, once it bonded through sulfur, or may bonded through nitrogen. If Cn is there, it may bonded through carbon or bonded through nitrogen. So that type of linkage, so change in the linkage, coordination bond is formed by the different atoms of the same ligand. Then that type of isomerism is called as linkage isomerism. So when this linkage isomerism is possible, when the ambidentate ligands are present in the coordination compound or a complex. So the next one is coordination isomerism. So coordination isomerism is here we are considering two different complexes, two different coordination complexes. So in that, if the cation or metal ion exchange takes place or anion species exchange takes place. If the metal ion exchange takes place or anion exchange takes place, then the coordination bond or the nature of the coordination bond changes. So that results in what? Coordination isomerism. So the next one is here hydrate isomerism. Hydrate name itself says about what? Water molecule. So if the water molecule bonded to the central metal atom in a secondary linkage is different in number in different compounds, but they are having same molecular formula, then they are said to be what? Hydrate isomers. As water is used as a solvent, so this is also called as solvent isomers. Thank you.